Welcome to our deep dive, all about Python and how to really boost your Python skills with test-driven development.
TDD?
Yeah, TDD, exactly.
That's a hot topic.
It is, and we're going to be looking specifically at this World Insider 2024 article, Python TDD Mastery, as our guide.
Oh, it's a great article.
It is, yeah, it's packed with so much.
A lot of good stuff.
We'll pull out like the key things and really see how we can use this approach to write better code.
Absolutely. I think TDD, it's becoming essential really in today's software development world.
Yeah.
And we'll uncover the core principles and the practical tools and even peek into the future a little bit of this approach.
Cool. Yeah, I'm excited to dive in.
Yeah.
It seems like everyone's talking about the need for clean, reliable code these days.
Yeah.
The article really kind of hits that home.
Yes, absolutely. The days of like messy code and just hoping for the best are long gone.
Right.
Think of it like building a skyscraper.
Oh.
A shaky foundation leads to disaster, right?
Yeah.
So TDD helps you build that rock-solid code from the very beginning.
Yeah, makes sense. And they have some impressive stats in there to back that up.
Yes.
There's some Cambridge University research that found companies using TDD have like 40 to 80% fewer bugs.
Yeah, it's huge.
That's incredible.
It saves so much time, money, and stress down the line.
It's a game changer for sure.
Absolutely.
One thing that I thought was interesting is that they emphasize that TDD is not just a testing phase.
Right.
It's more than that.
It's a fundamental shift in how you think about designing software.
Yeah, so how does that, how do we switch our brains to that? How does that work?
Right.
This idea of writing tests before you even write any code.
Right.
It feels a little counterintuitive, you know?
It does.
Would that not slow us down in the development process?
That's a common misconception, actually.
Okay.
While there might be a small learning curve initially,
Okay.
the time you save on debugging and maintenance later, it more than makes up for it. By writing the test first, you're essentially creating a blueprint for your code.
Yeah.
It forces you to think through the functionality, the inputs, the outputs, and potential edge cases, all before you get lost in the weeds of actually implementing the code.
So it's like having a clear roadmap. It's like, okay, this is where we're going, and we're not going to, veer off the path.
Exactly.
We're going to get to our destination.
Precisely. And the article illustrates this beautifully through this classic red-green refactor cycle.
Okay.
And they use a simple example of building a calculator in Python.
Okay, so how does that red-green refactor work?
So you begin with a failing test. This is the red phase.
Right.
Because, well, the code doesn't exist yet.
Of course, yeah.
Then you write just enough code to make that test pass, and that's entering the green phase.
Okay.
It's about just focusing on the immediate task at hand.
Right, no over-engineering,
Yeah.
just solve the problem.
Yes. And then finally comes the refactor phase, where you can kind of go back, polish, and optimize your code.
Okay.
And the beauty is you have that safety net of your tests, so you can refactor confidently and not worry about, breaking things or introducing regressions.
Like a trusty sidekick.
Exactly.
Looking over your shoulder.
Keeping you safe.
So you don't mess anything up.
That's it.
I like it. I like it. There's a bunch of myths around TDD as well. They go into debunking.
Yes.
One of them was this idea that you need 100% code coverage.
Oh, yeah. That's a big one.
Which it sounds like you don't need, it's not about exhaustively testing every single line of code.
Right. Exactly.
Right.
The focus should be on strategically testing the most critical parts of your code.
Yeah.
The ones that have, the biggest impact on your application's functionality.
Right. Okay.
And where bugs would have the most severe consequences.
So it's like quality over quantity when it comes to testing. That makes sense. That makes a lot of sense. So let's get down to the actual, how do we do this?
Right.
How do we put TDD into practice with Python? And they mention some really good tools in the article.
Yes, they highlight popular frameworks
Yeah.
like PyTest, Unitest, and Nose2.
Right.
Each has its strengths and weaknesses.
Yeah, so for someone like me who's eager to learn but not, a hardcore seasoned developer,
Sure.
PyTest seems like the way to go.
Yeah, it's great for beginners.
You mentioned it in the article, right? It's simple.
Yes, very intuitive syntax, very user-friendly.
And it has a large plugin ecosystem too.
Absolutely, very versatile.
So that makes it you can really customize it
Exactly.
for what you're doing, which is pretty cool.
And there's a great community around it as well. Lots of support available online.
Yeah, okay, great, great. And now they also mentioned some more advanced kind of TDD techniques like mocking and stubbing.
Yes.
And I have to admit, those always sounded a bit intimidating to me.
They can seem a bit complex at first, but they're incredibly powerful tools.
Okay.
They really are.
So what is like mocking and stubbing?
So they allow you to isolate parts of your code and test them independently,
Okay.
especially when you have those parts that depend on external systems or really complex interactions.
Yeah. Okay.
Let me give you a concrete example.
Yeah, please.
Imagine you're testing a function that's supposed to send emails.
Right.
You wouldn't want to send real emails every time you run your test, right?
Yeah, my inbox would be flooded.
Exactly.
And also, like, what if something goes wrong?
Exactly. It could have unintended consequences.
Yeah.
So mocking allows you to create a dummy email sender.
Okay.
It mimics the real one, but it doesn't actually send anything.
Oh, I see.
So your tests are fast, reliable, and your inbox stays clean.
Right, right. So it's like a stand-in
Exactly.
for the real thing, but lets you focus on what you're actually trying to test.
Exactly. The core logic of your function without worrying about those external dependencies.
I see. That makes a lot of sense. Okay. So we're not actually sending emails, but we're testing that the function is doing what it's supposed to do.
Precisely.
Okay. And then they also talk about integration testing,
Yes.
which takes a broader view, right? It looks at how different parts of your code work together as a whole.
Exactly. It's the next step, right?
Yeah.
You've tested individual units of code. Now you want to see how they interact, how they perform as a team.
As a team. Yeah, I like that analogy. And they have some cool case studies in there as well, like real world companies that are doing this.
Oh, yeah, some great examples.
The Spotify case study really stood out to me.
That's a good one.
So they shifted to a microservices architecture
Right.
and embraced TDD, and they saw a 47% reduction in production incidents.
It's huge, isn't it?
That's incredible.
Less time firefighting, more time building great software.
Yeah, and less stress too, right, for the developers?
Oh, absolutely. Happier developers, happier users.
Everyone's happy.
Exactly.
Which is, I mean, that's the goal, right?
That's the dream.
That is the dream, yeah. And then they mentioned the NASA Mars rover,
Oh, wow. Yeah.
which is like, that's pretty mind-blowing.
That's next level.
Right, so you're using TDD to build software that controls a rover on another planet.
That's incredible. It really shows the power and reliability of this approach.
It really does. Like, that's where you really got to be sure your code's doing what it's supposed to do.
Absolutely. The stakes are high.
Yeah, very high.
Oh, yeah.
Okay, so TDD sounds fantastic, obviously,
Yeah.
but it's not always easy to implement, right?
Of course, it has its challenges, like anything new.
What are some of the roadblocks that people run into?
Well, one common one is just managing the complexity of your tests as your project grows.
Yeah.
Imagine you have hundreds or even thousands of tests.
Right.
If they're not well organized, it can become overwhelming.
Oh, yeah,
It
totally.
can become a tangled mess that's difficult to understand and maintain.
Yeah, like a jungle. You
Yeah.
can't find your way through.
So the article emphasizes the importance of structuring your tests effectively.
Yep.
Clear naming conventions, grouping related tests together, breaking down complex tests into smaller, more manageable units.
Right.
All of these things help create a system that's easy to navigate and understand.
So it's like applying the same principles of good code organization to your tests.
Exactly. Consistency is key.
Makes sense. Makes sense. And then what about like dealing with external dependencies like databases, APIs, third-party libraries, all that stuff?
That's another great point, and it can definitely be a challenge
Right.
because you don't always have full control over those external factors.
Yeah.
So how do you test your code reliably when it relies on things that might change or behave unpredictably?
Right. Your test could be passing 1 minute and failing the next
Exactly.
because of something outside of your code.
That's where those techniques we talked about earlier, mocking and stubbing, become really crucial.
Oh, okay.
They allow you to simulate the behavior of those external dependencies.
I see.
So you can create a controlled environment for your tests.
Right. So like it's like a little sandbox where you can
Exactly.
play around and not break anything.
Precisely. And you can be confident that your tests are consistent and independent of the external world.
I like it. I like it.
It's all about control and isolation.
Right. Yeah. Yeah. Okay, that's a really good point. And then they also talk about refactoring as being a key element of the TDD cycle.
Yes, absolutely.
So it's not just about writing code to pass the test. It's about continuously improving the design and readability of your code as well.
Exactly. You want your code to be elegant and maintainable, not just functional.
Right. Right.
And that's where the safety net of your tests really comes in handy.
Right. You can refactor confidently, knowing that if you break something, your tests will let you know immediately.
Exactly. They'll scream at you.
They'll tell you, hey, you messed something up.
Exactly. Go back and fix it.
Go back and fix it. Yeah, okay. So it's a very iterative and controlled approach.
It is. It's about making small changes, testing frequently, and always making sure that each step forward doesn't introduce any regressions.
I like it. It sounds very methodical.
It is. It's a process, but a rewarding one.
And it leads to better code in the end.
Absolutely.
That's the goal.
That's what we're all striving for. Yeah, it's a continuous process of improvement.
Okay, so that's like on the code level, but what about like getting the team on board with this?
Yeah, that's another challenge altogether, isn't it?
Right, like I can see how it would benefit me, but how do you get, an entire team, especially if they're used to doing things a certain way,
Right.
to kind of switch their thinking?
Yeah, it's a valid concern.
Yeah.
The article suggests, starting small,
Okay.
maybe with a pilot project, something
Yeah.
where you can really showcase those tangible benefits.
Right.
And providing training and support to team members is also really crucial.
Okay.
You want to make sure everyone feels comfortable with this new approach.
So it's about leading by example and kind of creating that environment where people feel safe to try new things and experiment.
Absolutely. It's a learning process for everyone.
Yeah, speaking of learning, one of the things that really stuck out to me was how they emphasized using TDD to improve code documentation.
Oh, yeah, that's an interesting one.
Which sounds counterintuitive. Like how can tests be documentation?
Right, it's not immediately obvious, is it?
No.
But think of your tests as executable specifications.
Okay.
They clearly outline how your code should behave in different scenarios.
Right.
They define the inputs, the outputs, the expected results.
I see.
If your code doesn't align with those specifications, the tests fail.
Right. So instead of relying on comments or separate documentation files.
Right, which can get outdated quickly.
Yeah, exactly.
You have these living, breathing examples of how the code actually works, all thanks to your TDD process.
Okay, that's cool. So it's like the tests are the documentation.
Precisely.
And because you're running those tests all the time, they're accurate.
Exactly. They're always up to date.
Yeah, that's a good point. Okay. So we're not ditching traditional documentation altogether, right?
No, of course not. There's still a place for that.
Okay.
For providing context, explaining design decisions,
Right.
things that might not be obvious just from looking at the tests themselves.
It's about finding that balance, right?
Exactly. Using the tests as that primary source of truth for how the code behaves, and then supplementing that with human-readable explanations where needed.
Right. Okay, that makes sense. So let's talk about best practices for building a good testing foundation.
Okay, sure.
They go into code coverage as a key metric,
Yeah, that's a big thought.
but not about chasing 100% coverage at all costs.
Right, it's not about the quantity, it's about the quality.
Right. Yeah, we talked about that earlier. It's about focusing on the areas where bugs would have the biggest impact.
Exactly, the critical parts of your application.
Okay, so what's a good target to aim for?
Well, they recommend something like 80% line coverage is a good starting point.
Okay.
That ensures that a significant portion of your code is being exercised by your tests
Right.
without getting bogged down in trying to test absolutely everything.
Okay, but it's not just about the number of lines, right? There are different types of coverage, like branch coverage, which looks at decision paths in your code.
Absolutely. You want to make sure you're not just testing the happy path, but also those edge cases, those left common scenarios where your code might behave differently.
Right. Okay.
And thankfully, there are tools that can help you visualize your coverage and identify those potential gaps.
So it's like having an X-ray into your code
Exactly. You can see where you might be missing some tests.
and make sure you're covered.
Exactly.
Okay, cool. They also emphasize test organization and structure,
Oh, yes, that's crucial.
which sounds like it could get really messy if you're not careful.
It can. A poorly organized test suite is a nightmare to maintain.
Yeah, it's like a workshop where everything's just all over the place.
Exactly. You can't find anything, you're wasting time.
Yeah, it's chaos.
So how do you prevent that chaos? Well, the article suggests, again, following those same principles of good code organization,
Okay.
structure your tests in a way that mirrors your code base.
Okay.
Group related tests together. Use clear, descriptive names.
Makes sense.
You want to make it easy for anyone, including yourself, to understand what each test is doing.
Right. It's like you're writing code, but you're also writing code to test the code.
Precisely. And you want both to be as readable and maintainable as possible.
Okay. And then they introduce this arrange act to suit pattern,
Oh, yes. That's a
which
classic.
which is a way to structure individual test cases, right?
Exactly. It's a simple but effective way to ensure consistency and readability.
Okay, so how does that work? Can you walk me through it?
Sure, so in the arrange step, you set up everything you need for your test.
Okay.
Create objects, initialize variables, maybe establish connections to external systems, whatever's required.
Okay, so that's like the setup phase.
Exactly.
Okay.
Then in the act step, you execute the code that you're testing.
Right?
Call a function, invoke a method, perform some action.
Okay.
And finally, in the assert step, you check whether the outcome of that action matches what you expected.
Okay, so you're like verifying that everything worked as planned.
Exactly. Arrange, act, assert, a simple three-step recipe for well-structured tests.
I like it. It's a good recipe.
It is. It's a tried and true approach.
Cool, cool. And then they talk about integrating TDD with continuous integration and continuous delivery.
The SED, yes.
CI/CD, which is
Yeah.
all about automating the building, testing, and deploying of your software, right?
Yeah, exactly. It's about streamlining that entire process.
Okay.
So every time you make a change to your code,
Yeah.
it automatically gets built, tested, and if everything passes, deployed to your users.
Okay, so it's like taking that TDD mindset
Well,
and
that's
extending it to the entire development process.
precisely. It's about continuous feedback and continuous improvement.
I like it.
It's a powerful combination.
So you're always confident that your code is in a good state and ready to be shipped.
Exactly. You have that peace of mind.
And it's less manual work.
Oh, absolutely. It frees you up from all those tedious tasks.
So you can focus on the fun stuff.
Exactly. Writing great code.
Okay, now, as much as we love TDD,
Yeah.
it's not without its challenges. Like, we talked about some of them already, like managing test suite complexity, dealing with external dependencies.
Right.
The article doesn't shy away from that, does it?
No, it acknowledges those difficulties and offers practical solutions.
Okay, so like, what are some of the things that they suggest for overcoming these hurdles?
Well, for example, they go into detail about refactoring strategies in the context of TDD.
Okay, yeah, refactoring, that's all about improving the design and readability of your code without changing how it works, right?
Exactly. It's like cleaning up your code, making it more elegant and maintainable.
Okay.
And in a TDD environment, refactoring becomes even more important because you have that safety net of your tests.
Right, you can refactor confidently, knowing that you're not breaking anything.
Exactly. If you introduce a bug, your test will catch it.
So it's like having a safety harness while you're rock climbing.
I like that analogy, yes.
Yeah, you can take risks, try new things,
Explore different paths.
but you're always protected.
Yeah, you won't fall too far.
Okay, and then what about team adoption? Because we talked about that as being a challenge as well.
Yes, it can be.
So any tips for navigating that transition?
Well, the article emphasizes starting small, choosing a pilot project where you can really demonstrate the benefits of TDD,
Okay.
providing training and support to your team members,
Yeah.
and gradually integrating TDD practices into your existing workflow.
So don't try to like force everyone to change overnight.
Exactly. It's a process. It takes time.
Right. It's about creating that culture of continuous learning and improvement.
Absolutely. Where mistakes are seen as opportunities to learn
Yeah.
and where everyone feels empowered to contribute.
Right. So it's a team effort.
It is. Everyone's on this journey together.
I like it. I like it. Okay, so let's step back for a minute and talk about like the bigger picture.
Okay.
Why is TDD so important in today's world?
That's a great question.
What are the real world benefits that it brings?
Well, we've touched upon some of them already, but it's worth really bringing them to the forefront.
Yeah, definitely.
I think one of the most compelling arguments for TDD is that it leads to significantly higher code quality.
Right. Yeah, we've talked about how it helps reduce bugs,
Yes.
but it's more than that, right?
It's about creating code that's more robust, more reliable, more resilient to change.
Because you're thinking about all those different scenarios up front.
Exactly. You're anticipating problems before they arise.
It's like building a house with a strong foundation.
Precisely. You're not cutting corners. You're doing things the right way.
And that leads to like less stress in the long run.
Absolutely. Less firefighting, more time for innovation.
Yeah. Okay, so higher code quality, what else?
Well, this higher code quality translates into tangible benefits for both developers and businesses.
Okay, so let's break that down. Like, what does it mean for developers?
For developers, it means less time spent debugging, less stress dealing with production issues, and a greater sense of pride and ownership in their work.
Yeah. Okay, so happier developers?
Absolutely.
And what about for businesses?
For businesses, it means reduced development costs, faster time to market, and happier customers who are using software that just works.
So it's a win-win situation for everyone.
It is. It's about creating a sustainable and successful software development process.
I like it. I like it. And we can't forget how TDD encourages better design and architecture in your software.
Oh, absolutely. That's a key benefit.
So how does that work?
Well, when you write tests first, you're essentially designing your code from the outside in.
Oh,
You're thinking about how your code will be used, how it will interact with other parts of the system, how it will respond to different inputs and scenarios.
it's like a more holistic approach.
It is. It's about thinking about the bigger picture.
Right.
And that leads to more modular, maintainable, and loosely coupled systems.
Which is especially important in today's world, right?
Absolutely. With microservices, distributed systems, the complexity is constantly increasing.
Right. So you need that good design and architecture to keep things manageable.
Exactly. You need a system that's easy to modify, expand, and scale.
Makes sense. Makes sense. And then there's also the impact that TDD can have on team dynamics.
Oh, yes. We talked about how it can ease team adoption, but it goes beyond that.
Okay.
It can actually improve communication and collaboration within your team.
So how does that happen?
Well, when everyone participates in the testing process,
Right.
from writing test cases to reviewing test results,
Yeah,
it fosters a shared understanding of the code base
I see.
and a sense of collective ownership over the quality of the software.
It's not just the developer's responsibility anymore.
Exactly. It becomes everyone's responsibility.
And that can lead to a more cohesive team, right?
Absolutely. A more positive work environment
Yeah.
and ultimately better software.
That's cool. So it's like TDD is not just about the code, it's about the people too.
It is. It's about creating a better way to work together.
I like it. I like it. Okay, so we've seen how TDD can impact code quality, development costs, time to market, team dynamics. It's pretty impressive.
It is. It's a powerful methodology.
Yeah, it really is. Now, the article wraps up by taking a look at the future of TDD.
Oh, yes. The crystal ball.
Yeah, what's coming next?
There are some exciting developments on the horizon.
Like what? What are some of the things that they highlight?
Well, one trend is the integration of property-based testing.
Okay, property-based testing. What's that?
So it's a more abstract approach to defining test cases.
Okay.
Instead of specifying concrete input and output values,
Yeah.
you define properties that your code should satisfy.
Okay.
And the testing framework automatically generates test cases to check if those properties hold true.
So it's like setting up a set of rules.
Yeah.
And then letting the testing framework see if your code always follows those rules.
Precisely. It's a very powerful way to uncover edge cases and unexpected behavior that traditional TDD might miss.
Okay, so it's like taking TDD to the next level.
It is. It's about thinking more broadly about how your code should behave.
Right. Cool. Cool. What else? What other trends are they seeing?
Well, they also talk about the shift-left testing movement,
Shift left testing. Okay.
which is all about moving testing earlier in the development lifecycle.
Okay, so like catching bugs sooner rather than later.
Exactly. When they're cheaper and easier to fix.
Makes sense.
And this aligns perfectly with the principles of TDD, doesn't it?
Yeah, because you're writing tests before you write code.
Precisely. You're shifting testing to the very beginning.
Right, so it's like a natural fit.
It is. It's about building quality in from the start.
Okay, cool. And of course, we can't talk about the future without mentioning AI.
AI, the elephant in the room.
Right, it's everywhere these days, and it's starting to make its mark on TDD as well.
It is. And the article highlights some fascinating applications.
Like what? Give me some examples.
Well, one is AI-powered test generation,
Okay.
where machine learning algorithms can actually generate test cases for you
Wow.
based on your code, your requirements, even your past testing history.
So it's like the AI is learning how to test your code.
Exactly. It's pretty amazing.
That's crazy.
It is. And it has the potential to save developers a lot of time and effort.
Right, so they can focus on like the more creative parts of their job.
Exactly. The fun stuff.
Yeah, okay. And then they also talk about AI helping with test maintenance.
Yes, that's another big
It
list.
can be a real pain, right?
It can, as your code base evolves, you often need to update your tests.
Yeah, to keep them in sync.
And that can be tedious and error prone.
Right, yeah, okay. So
Yeah.
AI could help automate some of that.
Exactly. It could analyze your code changes and suggest updates to your tests.
That would be amazing.
It would free up developers to focus on more important tasks.
Okay, cool. So it sounds like TDD is on the verge of a major transformation.
It is. AI is changing the game.
Yeah, and it's exciting to see where things are headed.
It is. The future of TDD is bright.
And speaking of the future, the article also talks about how testing frameworks themselves are evolving.
Yes, they're keeping pace with all these changes.
So what are some of the key advancements that they highlight?
Well, they point out that modern frameworks are incorporating features like async testing support
Yeah.
to handle asynchronous operations, parallel test execution to speed up test runs,
Makes sense.
and container-based testing to ensure that tests run in isolated environments.
Right. Okay. So they're addressing some of the more complex aspects of modern software development.
They're making TDD more powerful and efficient.
Cool. And then they talk about like the reporting and analytics getting more sophisticated.
Yes,
So it's not just about pass or fail anymore.
right. You get much deeper insights into your tests.
Okay. So we can see things like code coverage trends over time, identify areas where our tests might be weak,
Yes.
even get predictions about potential test failures before they happen.
It's all about giving developers the information they need to make better decisions.
So it's like the testing frameworks are getting smarter.
They're becoming more intelligent and helpful.
That's awesome.
It is. It's an exciting time to be a developer.
It really is. Yeah, it feels like we're on the cusp of some major advancements.
We are. The possibilities are endless.
Yeah.
Yeah, it's really an exciting time to be in this field.
It is. It is. And like you said, these advancements, the property-based testing, the AI integration, it's not just about making TDD more efficient. It's really changing what we think is possible, right?
Absolutely. It's pushing the boundaries, expanding our horizons, really changing the way we think about testing and software development.
And the testing frameworks are keeping up. They're evolving, right? They're becoming
Yeah.
more powerful, more feature-rich.
Absolutely. They're adapting to the needs of modern software development.
You mentioned async testing support, parallel execution, container-based testing.
Yeah, all of these things are essential for dealing with the complexities of modern software.
And the reporting and analytics, you were talking about how that's getting more sophisticated.
Yeah, it's becoming much more than just a simple pass or fail. You get real insights into your tests now.
So we can see trends over time, identify weaknesses.
Exactly, and even anticipate potential failures before they happen.
Wow, it's like the testing frameworks are getting smarter.
They're becoming more intelligent and helpful.
It's pretty amazing to see how much thought and innovation is going into making TDD better.
Yeah, it's a testament to the value that people see in this approach.
It's clearly a methodology that's here to stay.
Absolutely. It's not a fad, it's a fundamental shift in how we build software.
So as we wrap up this deep dive, I think it's important to reiterate that TDD is not just about the tools and techniques. It's really a mindset, right?
It is. It's a way of thinking about software development that prioritizes quality and reliability.
It's about making testing an integral part of the process.
Exactly. Not an afterthought, but a core principle.
And while it might seem a bit daunting at first,
Sure, can be a learning curve,
yeah,
but the benefits are undeniable.
they are.
Better code, fewer bugs, faster development cycles, more confidence.
It's been really fascinating to explore this in depth. I feel like I've learned a lot.
Me too. It's always
Yeah.
good to revisit these core principles.
So for anyone listening who's maybe, on the fence about diving into TDD,
Yeah.
what advice would you give them?
I would say start small, choose a simple project, experiment with the workflow.
Okay.
Don't be afraid to make mistakes. That's how we learn.
Yeah.
And there's so many resources available, communities, books, articles, online courses. There's no shortage of help.
Yeah. Great advice. Great advice.
Embrace the journey, that's the key.
That's the key. And you'll be amazed by what you can achieve.
Absolutely.
Awesome. Well, thank you so much for guiding us through this deep dive. It's been incredibly insightful.
It's been my pleasure. Always happy to talk about TDD.
And for everyone listening, happy coding.
Happy coding.